In this video, I'm going to go over some more questions from the 2015 PAT. Okay, here is number 8 from the 2015 PAT. It's another word problem 1 where they've given us a diagram. Now I do want to just add that there are 2 ways to solve this question. I'll just go over one, but feel free to play around and see if you get the other way to solve it, and of course the answer is going to be the same. So let's go ahead and read our question. So the arch in the diagram below forms a complete half circle. The black support beam in the diagram is 3.6 meters in length, and 3 meters above the surface of the water. We need to calculate to the nearest meter the diameter of the arch. So a couple of key pieces of information here. We know it's a semicircle, so that means whatever we get for the diameter, we're going to cut that right in half of the whole circle. The second thing we know is that the length between the black bar to the center is 3 meters. So we've taken care of that, and they said the black support beam, which really just acts as another chord, is 3.6 meters. All right, so I think we're missing one piece of information. Sorry, give me a quick second here. Okay, sorry, okay, so now we need to figure out the diameter of the circle, meaning what they're asking us to do is they want us to figure out really this portion of that water. That's what they want to know, because we know it's a full circle. If it was a full circle, the diameter would be cut right in the middle. I actually think it's a little bit of an oval, but we'll go with it. And if we can figure out the length of that water, this portion here, then we can figure out the diameter. So now we're looking at this. We've got a chord, and we have, you guessed it, a perpendicular bisector. So that means we definitely can start to move our radius and try and get a right angle triangle. So if this is the diameter, half the diameter is the radius, meaning the radius is from here to here. Now, as I've said in this whole video, we can move that radius however we want. We can move it here, here. Well, really that would work, because that is going to get us our triangle, our right angle triangle. So I'm gonna go ahead and draw that in. Now in this case, we don't actually know the radius. That's what we're trying to figure out, because if we get the radius, if we get x and we double it, then we get our diameter. So that means we can use our same Pythagorean theorem. And in this case, we're trying to figure out c squared. So we have a squared. I'm just gonna say a squared is that vertical line at 3. However, we may be tempted to write 3.6 for the whole portion here, but remember, we're cutting this in half. It's a perpendicular bisector. So that means we have to go half of 3.6. So I just think of that as 36. Half of 36 is 18. So I can pop that decimal in, get 18 squared. Add those together after I square it. That's gonna get me 12.24 is equal to c squared. To get c alone, we're gonna go and take the square root of c, or 12.24. So c is equal to 3.5 meters. Now watch this carefully. In this test, they've made the 3.5 meters, excuse me, I can't get my units right today. They've made that option A, and they do that for a reason. Because what they're thinking is you're going to forget, your job is to figure out the diameter and not double it. And then you're gonna select A, but of course we know that that would be incorrect. So let's double our 3.5. Double 3.5 is going to give me 7 meters. So this is really the 3.5, and that's the 3.5. Combine that together is 7. So our answer is going to be C. So in this question, they gave us a linear relation. So if we remember, a linear relation is basically the coordinates on our graph are able to make a straight line. So that means both x and the y-intercept are increasing at the same rate. So we can see that here. Our job is looking at the linear relationship. We need to figure out the x-coordinate when y is equal to 3. So one of the first things we can do with something like this is we can actually connect the dots together to figure out what the relationship looks like. This helps us find any points that are not plotted on the graph, but are still within that line or still within that linear equation. So now what we're gonna do is we're gonna find out our y point. So it says here when y is 3, so y is 3 would be right there. And I'm gonna draw it out until I hit my line. Once I hit my line, I then can go down in order to figure out the x-coordinate. So now all of a sudden we know that when y is 3, if I move it across and it hits our linear relationship, our x is going to be right here. So that number is in between 6 and 8, so that means our number here is going to be 7. Okay, number 10 here. So we're looking at some data here. So the question says, a manager selected 25 watches to test from a batch of 750. He determined that 3 of the selected watches were defective. So out of the 25 he took, 3 of them weren't working. From there, he kind of took those results and said that 12% of the 750 watches were defective. So which of the following assumptions did the manager use to reach his conclusion? So let's go through our options and decide what's going to work best here. So the process for testing watches was unreliable. Well, we actually don't know the process of what he did for testing this one, so we can't actually use that one. The parts used in the watches are rarely defective. Again, we don't have any information that indicates the parts inside these watches. So that one would not work. The sample was representative of the population. So I do like this one. We're looking at the total population being 25, out of the 75. So what we did is we took a sample population, just a little bit, and then we said from that little part that we took out, how much of them are defective. So I do like that. Let's double check D. The watches were made by the same employee. Again, we have no information indicating that the watches were made from the same employee. So our best answer for this question is going to be C. Okay, question number 12 here. So this question is kind of interesting. So we have the area, which is represented with A of these 4 carpets. And what we do know about these 4 carpets is that they are all squares. Okay, so we gotta keep that in mind. That's gonna be important. We wanna know which square carpet will cover the most floor area without touching the wall when it's laid flat on a square room that has a width of 4.5. So a couple of things here to note. So the first thing is, in the room that we're going to put the carpet in, it's going to be a square. We're going to pretend my drawing is a perfect square there. And we're saying it's 4.5 times 4.5. So that would be the width of it. So the area means for this question, 4.5 times 4.5 is going to be 20.25, okay? So that means the closest I can get is going to be, if I go with carpet, is going to be carpet 2. If I go with carpet 1, it's 13. That's going to leave quite a bit of space. Carpet 2 is going to fit quite nicely in there with just a little bit of edges around it. Carpet 3 is probably going to be way too small. And carpet 4 is going to be too big. It's going to exceed our area. So that means our option for this is going to be carpet 2. Now there is another way that we can also solve this question. The other way that we can do this is we can take the square roots of each of these carpets. So let me back that up a second just to make sure we understand this concept. So we know that area is equal to length times width. Well, in a square, that area is equal to the same number times that number. So for example, if my area was 16, we know a square, which means all the sides are the same, would be 4 times 4. So that means if they gave me the area of 16 and I were to take that square root, it means that the side length of that room would be 4, okay? So in a question like this, if for some reason we choose not to use this method, or for whatever reason the question's different and we can't use this method, we can take the square root of each of these and find the side lengths, and that side length has to be a little bit smaller than this 4.5. So we could use our calculator for this. So the square root of 13 is going to be 3.6. Square root of 18.5 is about 4.3. And again, that really does fit in our dimensions of that question. The square root of 22 is going to give me a side length of 4.96. And then finally, carpet 3, a square root of 4.4 would give me a side length of 2.09. So the one that's going to fit closest with our side length still matches up to be carpet 2. Okay, number 13 here. So this is a little bit tricky, so just take your time with it, and then as always, let me know if you have any questions in the comments below, okay? So the cost of renting cars includes the base fee and the charge for each kilometer driven. The graph below represents the total cost of renting a vehicle at 4 different rental car companies. So one of the things we want to be clear about this is when you rent a car, in this case here, you're going to pay what's called the base price. So that's just the amount to rent the car. And then you're paying for how many kilometers you're actually driving it. So in this graph, what they've done is they've given us our total cost, and our job is to figure out the kilometers driven. And we want to figure out which one has the smallest kilometers driven. Now, what I did before I started filming was I actually put in these parts of the graph. So these graphs can get really, really tricky. I'll just show you a quick example. So on the x-axis, the original x-axis, it looked like this. So what I did is I went in and I said, well, okay, we go from 0 to 80 with 1, 2, 3 spots in between. So if I were to fill that out, it's going to be like I'm skip counting. So 2, 4, 6, 8. Now, because we're dealing with tens, I can start popping in a 0 to fill in my y-axis, sorry. So that means each little space here is actually $20 jump. And same idea with the x-axis, each little space here is a 5 kilometer jump. Now that's going to be important for when we think about how to read this graph. So what I actually want to do here is we're going to look at our different companies. So all the ones that are listed here. And then from there, we're going to decide the base cost and the total, and we're going to fill it out in a chart. Now, I'm using a chart just to save room, and so it's nice and neat when you all are watching it. When you're doing the exam, feel free to work however you want. I do recommend a tiny bit of organization in terms of labeling the company so you don't get confused. But let's start it off here. So our base price for company W, which is this circle one here, our base price here is $20. And we can see that it lines up really nice there. Our base price for company Y is going to be 40. We can see that the one with the triangle here, so that's going to be $40. We'll just zoom in on that. And then our base price for company X is going to be $30. We can see it sitting right in the middle of 20 and 40. And finally, our last one has a base price of 50. And again, it's sitting right in the middle of our 40 and 60, so it's going to be 50. Now let's look at our total prices. So our total prices for each company. So for company Y, our total price, if we read the graph, is going to be, for company W, is going to be about 70. We can see it's kind of sitting right in the middle there. Our total price, when I'm reading for, let's say company, I'll just go with the one above it. So company Z, that one looks to be a little bit higher than 70. So I'm going to say it looks about 75. And then finally, company Y, that one's sitting quite high. So company Y to me looks about 110. And we can see that it's sitting right in the middle of 100 and 120. So that's about 110. And then finally, our last one looks like it's sitting at about 130. So that's our cost. These are all the dollar amounts. Right, I'm reading that on the y-axis, and these numbers here are the base price. So what I did is I put that in a chart here. So let me show you that chart. So I took all of our base prices here and I wrote them down next to each company just to keep me organized. And then I said, well, what's the price at 50 kilometers, which is the total price that they're charging. Now what we need to do is, because we need to figure out each kilometer driven, we're actually going to go ahead and subtract these values. So I'm going to go 70 take away 20 just to get the kilometers is going to give me 50. So basically it means it cost $50 once we remove that base price. For company X, we're going to go 130 take away 30. That's going to give me a cost of $100. For company Y, for company Y, that's going to give me a cost of 70. And for our last company, that gives me a cost of 25. So what this means is once we remove the base price, we know how much they were charging roughly each kilometer. Now what we need to do is figure out what that's going to be for kilometers driven. So to do that, we're going to divide it by the total number of the 50 kilometers here. Of the 50 kilometers here that they gave us in the graph. So that's our total. We've got our kilometers. Now let's figure out what it is. We've got our price. Now let's figure out what it is for our 50. So I'm going to go, I'll zoom in on this as well so we can see what we're doing here. We're going to go $50 over 50 kilometers. And again, that 50 kilometers is just coming from the graph because that's how we got our total cost right here when we zoom in at that 50. This one here is going to be $100 per 50 kilometers. This one's going to be $70 over 50 kilometers. And our last one is going to be $25 over 50 kilometers. So we can punch that in using a calculator to get our actual kilometers driven. So this one is just going to be $1 per kilometer driven. This one is going to be $2 per kilometers driven. This one's going to be 1.4. And finally, our last one is going to be 50 cents. So that means our last company is our answer. So the answer to this question is question D. Okay, I was just going through the footage of the previous question, question 13. I just want to make it clear as to why we did the subtraction, okay? So what I did is when you think of formulas for linear equations, it's going to be your base price plus something times X, which equals the total cost. So in our graph, they gave us the total cost at 50 kilometers, which is what I figured out with this part of the chart here. So that part's taken care of. Our base price, again, I figured out with our graph and I put that in this portion of the chart. Now what I did is I subtracted to get the kilometers driven, okay? But that kilometers driven is just the amount of the total. Then what we have to do is subtract it by the 50 kilometers, which again is our total that was given in the graph, to get the rate. And the rate in this case is the charge for the kilometers driven. Okay, so again, if you have any questions on that, let me know in the comments below and I will do my best to answer them for you. Okay, numerical response number 3 here. So we've got some wind turbines and we can see that there's 4 of them. And one thing I noticed right off the bat is they're increasing in height. So our job is to look at the blade length and the height of the wind turbine and determine the two that are proportional. So with proportional, what we're saying is we're really looking at scale factors here. And we want to know which scale factors would be the same, indicating that the 2 turbines are the exact same. One is just a bigger version of it, or one of it's a little version of it. Okay, so what I'm going to do is I'm looking at this, and we know we've got the blade compared to the height. So I know that in each of these cases, the height is always taller or bigger than the blade. So for simplicity's sake, in order to figure out the proportions of this or the ratios for it, I'm going to take the height. In fact, I'll write it here. I'm going to take our height and then divide it by the blade. Now, technically speaking, you can do it the other way around. You're just going to get a little bit of, I guess, awkward decimals, if you will. So in this case here, I'm going to go 18 divide by 10. That's going to give me 1.8. I'm going to go 30 divide by 18. That's going to give me 1.6 repeating. And yes, you can use a calculator for this one. For turbine 3, I'm gonna go 45 divide by 27. Oh, I'm liking this one. This one gives me 1.6 repeating as well. And for my last turbine, it's gonna be 63 divide by 32. That one is close, but not quite. It's 1.9. So the 2 that are proportional are the ones that give me the same answer when I'm dividing them and getting the same ratio. That means turbines 2 and 3 are proportional to one another. Okay, number 14 here. So this one can be a little bit tricky because it's actually using 2 different rules. So not only is it a surface area question, we also have to know our rules about powers or square roots. So let's read the question. The following 3D object is composed of identical cubes. So here are our identical cubes. The volume of each cube is 8 centimeters cubed. So volume is length times width times base. And because it's a cube, we know all the 3 numbers are the exact same. So that means we need 3 numbers that are the same, that when multiplied equal to 8. So this is where if you can think about your cube roots, or you can think about powers, we know that that number is going to be 2, right? Because 2 times 2 times 2 equals 8. If you didn't know that right off the top of your head, you can always play around with the numbers until you get something that works. You will get there. So now our job is to figure out the total surface area of this 3D object. Now what's tricky about these 3D objects is, of course, you only see a 2D version. So we need to use our mind here. We need to really think about the sides that we can't see. So the first thing that I do notice is that if it's just a face, like a regular face, it's going to be 2 times 2. So that means the surface area is going to be 4. Now, for those of you that don't remember, surface area is a fancy way of saying what would happen if we wrapped up everything in wrapping paper. How much wrapping paper would we actually need? So then if I'm looking at this, I'm saying, okay, well, I know for sure I'm going to need 2 for the first face, excuse me, 4 for one of the faces. So now I have to see how many faces I have. So right off the bat, I know with the front that would be this portion here kind of facing me, I know I'm gonna have 3 of those. And so you can just imagine visualizing it, looking at it, and you would see 3 in a row there. I also know for the back, I'm also gonna have another 3. And that makes sense, right? So even though this portion is sticking out, if I were to rotate it, I would see 3. And same thing with the back. Now on the right, that's like the side that we can see. Again, we know we've got 3 as well. And then with the left, same idea. And then we have to get really, I don't know if the word is creative or really imaginative of what the top and bottom looks like. So the top, I actually can see it quite well. It looks like a little box here made up of 5 different cubes. So kind of like a plus sign made up of 5 cubes. And that means the bottom, which we know is symmetrical, is going to look the exact same. So that means altogether, if I add up every single thing here, this means I have 22 faces. Now, I just want to take a moment here and say, if this isn't making sense and you've got time before your PAT, either with whatever things you've got at home, whatever cubes you've got at home, or hopefully it's a little bit earlier before your PAT and you can borrow or take a look at the cubes that your teachers might have, is to build this shape, just to really strengthen that spatial awareness and making sure that we know all the different parts that we can't see on a 2D image that exist on a 3D image. Okay, so now that we know it's 22 faces, and we know that each face has a unit of 4 centimeters squared, we're gonna go 22 times 4 centimeters squared. That's gonna get me to 88. So our answer for this one is 8 centimeters. Number 15. So this would be one that I would say would be pretty good as a mental math portion of the PAT with maybe small variations in numbers. So just keep that in mind when we're doing this. So we have an equation. We need to figure out the value of x, and we have an equation where we have x on both sides. We also have a number outside the bracket. So my key for remembering that is actually something I heard from another student, is we're gonna rainbow in that number from that number that is outside the bracket. So we're just gonna go ahead and rainbow that in. So that means I have 3 times 2x, well that's gonna be 6x. And then I have 3 times -1, that's gonna give me -3. And that's equal to everything on the other side. So half times x would just be a half x, plus half times 6. So for this, and if we think of a half times 6, I'm gonna word it this way. What is half of 6? So if I have 6 things and I took away half, that's gonna leave me with 3. So that one can just stay a 3 there. So now I can start to move things around and combine everything a little bit. So what I always say for this one is when we have variables on both sides, we almost always want to move the small x. So I'm going to move the -1/2 x over to the other side. And sorry, I'm moving the positive half x by adding a -1/2 to both sides. And then you're going to hear me say this a lot when it comes to algebra, we are going to rewrite everything. And then that's going to equal to positive 3. Now what I can do is I can move this 3 onto this side. And just as a friendly reminder, the reason I'm doing this is I want to get x's on one side and I want to get numbers on the other side. So that's going to leave me with that's going to leave me with 6x, take away a half x equals 6. So now what I want to do is I need to combine this. So we are technically here, we're subtracting fractions. With our 6x, it's going to need what's called a common denominator to subtract it from the bottom there. That means what I'm going to do is I'm going to multiply both sides by 2. And the reason I'm multiplying both sides by 2 is because every whole number has an invisible 1. So by multiplying it by 2, now they can have the same denominator. So that's going to look something like this. 12x take away x over 2 is equal to 6. All right, so now I can combine that a little bit further. 12x take away x is really just going to be 11x over 2 equals 6. Now I'm looking at this and I'm not a fan of that 2 in the denominator, so let's get rid of that because our goal is to always get x alone. So to get rid of that, I'm going to multiply both sides by 2. That's going to leave me with 11x. And I'll write this off just to say that it cancels off. Sorry, that should have been a 2 there, not a 12. There we go. That's going to leave me with 11x on the top is equal to 12. To get x alone, x is being multiplied by 11, so I'm going to divide both sides by 11. So x is equal to 12 over 11. So our answer to this one is going to be answer B. Okay, number 16 here. So the PAT really loves these kinds of questions. What they do is they give you a question and then they tell you 4 students came up with an answer, which one is the correct answer. So that can get a little bit tricky because those answers, like the student answers, are made with common errors that lots of kids make. So what I recommend is let's ignore their answers. Let's just completely ignore it. Now let's go ahead and solve this question here. So it's a polynomial and we've got I'll rewrite it here. So we have 3x times 4x minus 6 over 2 bracket 3x. So what we want to do is we want to rainbow in those numbers on the outside. So I'm just going to do that like we did in a previous question. And now we're multiplying. So 3x times 4x, that's going to give me 12x squared. Now remember, with those exponents, it's 1 times 1, so we can add those exponents, giving us x squared. For the last one, it's just 3x times 6, so no variables there, so that's just going to be 18x over the bottom, which is going to give us 6x. Oops. All right, so now with this, we can actually go into our rules of dividing polynomials. So I like to split it up like this. 12x squared over 6x take away, or negative, 18x over 6x. Now let's simplify each one and then we can bring it back together. So these exponents here are going to get subtracted. That's going to leave me with just x. And 12 divided by 6 leaves me with 2. Then I'm going to bring down that negative and then focus on just the 18x over the 6x. So 18 take away 6, or 18 divided by 6, no takeaway. Well, actually, I shouldn't say that. Technically, we're going to take away the degree of 1 on both x's, which gets us to 0, which we don't need to worry about, right? So they cancel. And then we can say, well, what's 18 divided by 6? 18 divided by 6 is 3. So our answer is 2x minus 3. So let's see which of these kids said that. All right, so it looks like student 2 said that, making our answer B. Okay, number 17 here. So 2 things I want to point out with this question here. So the first thing is we are going to need to use our BEDMAS rules for this. So I wrote that at the corner right here, just in case if you forgot what that's going to be. So we do want to follow that. Second thing is, with our question, what they did is they gave us 2 letters here, and they said this represents the integer, this is represented in the integers below. So we know that P could be any of these numbers and Q could be any of these numbers. The other thing that's kind of tricky is they're also testing you on how much you remember operations with integers. So what I did here is I filled out a little template, or I made a template that we can fill out with whatever it is that we decide for P and Q to be. So before we get into it, I do want to show you two things. So we know P is going to be cubed, and we know P is either going to be positive 2 or negative 2. So I'm going to show you how that works when it comes to thinking about the sign. So if P is negative 2, what we're saying is negative 2 times negative 2 times negative 2. And that's just coming from the fact that it was cubed here. So if that's the case, then I'm going to go ahead and say, well, negative 2 times negative 2 is going to give me positive 4 times negative 2 again. Now I'm putting that negative 2 in brackets just to give it a little hug. So 4 times negative 2, that's going to give me negative 8. Now, if that didn't make sense, I want you to take a peek at this video here, where I actually go through all the operations with integers. If that made sense, then let's focus back on one of the exponent rules regarding negative numbers. If the exponent is odd, and the integer is negative, the sign is always going to be negative. Okay, that's the opposite if the sign is positive. Now let's look at what happens if we substitute in the positive 2. Well, if I substitute in positive 2, I'm basically saying 2 times 2 times 2, which we saw in a previous question. So that's going to give me 8. Positive 8 this time. So that means if P is negative, we're going to get negative 8 in the exponent, and if P is positive, we're going to get positive 8. Okay, so let's fill in our numbers here. So for option A, we're saying it's negative 2, and we're saying for Q, it's also negative 2. Now, like I said, we have to follow our BEDMAS rules, okay? So negative 6 divided by negative 2, that's going to give me positive 3, right? Negative divided by negative is a positive. And then I can look at the rest of my stuff here. I have negative 2 times, or excuse me, let me rewrite that out actually. So we know negative 2 cubed is 8, so I'm going to say we have 2 times 8 plus that 3 that's hanging out. I'll just bring that up. It's hanging out right over here, coming from that negative 6 divided by 2. So 2 times 8, because we're following our BEDMAS, our next step would be multiplication. That's going to be negative That's going to be negative 16 plus 3. Well, that's going to give me an answer of negative 13 because I have more negative things. I have 16 negative things and I'm adding positive 3 to that. So that answer is going to be negative 13. Okay, let's try it again. Same thing, but we're going to switch those numbers. So for P, we're looking at a positive 2, and for Q, we're looking at a negative 2. Okay, same thing as last time. We're gonna say, we'll do our division first. So negative 6 divided by negative 2. Again, that's still going to be the 3 that we got last time. And where it changes is in this case, we get 16 plus 3, okay? So that's gonna leave me with 19. All right, let's look at the next option. So for option C, we're saying negative 2 and positive 2. So we'll start with our division as always. Negative 6 divide by 2. So we're taking a negative, dividing it by a positive. That's going to give us negative 3 this time, okay? And then with our 2 and negative 2 to the exponent of 3, well, that's going to be 2 times, we know if it's a negative exponent of 3, that's going to be negative 8. And then now we can multiply that. That's going to be negative 16. And we're adding negative 3 to that, okay? So I need you to picture this really clearly. We've got negative 16, so 16 red tiles, and we're adding another 3 red tiles. That means altogether, I'm going to have negative 19 here. All right, last one. I know this one's tedious, right? And the numbers are so similar. So we're almost there, but I feel you if you're feeling a little exhausted. Okay, our last option is positive 2 and positive 2. So just as before, we're gonna look at our negative. So negative 6 divide by positive 2, that's gonna get me negative 3. And then we know when it's a positive 2, it's gonna be 8. So 2 times 8 is 16, and we've got the takeaway 3. So 16 take away 3, that's gonna leave me with 13. So our answer for this one is 13. Now, what again can also be tricky about this question is we wanna know the lowest value. So we need to be really clear that the lowest value means the most negative number, the one that's furthest away from 0. So in this case here, our number that's furthest away from 0 is going to be option C. So our answer for this is C. Okay, number 18 here. So we've got an interesting question. So we've got each gray square in the design below has an area of 77.44 centimeters squared, and each black square has an area of 4.84. So this kind of goes back to that previous question we talked about with squares. So one of the things I'll remind you of is when we think of area, we're saying length times width. But what happens here with a square, we're saying that area is equal to the same length times the same width. So an example of that, I'll use a different number this time, would be like, let's say the area is 4. We know that that means the side length has to be 2, because 2 times 2 equals 4, or the square root of 4 equals 2. So as long as it gives the square, if we take the square root of the area, we can figure out the side lengths. Now, this question again was made before the mental math portion of the PAT. While we can use estimation, I would say for this one, we can probably use the calculator. Most of the time, if it's an estimation one, you'll probably get the number to the nearest tenth, or probably a nearest whole number. It's just not going to be a perfect square, okay? So again, we'll use our calculator for this one. So what we want to do is we know the gray is 77.44, and the black one has an area of 4.84. So our job is to figure out the side length of this. Let me actually read out the whole question. So our job is to figure out the side length, but we need to figure out the whole height of this design here. And we can only do that with the side length, right? So what I did here is on the side, I pulled up a scientific calculator to show you how this works. So what I'm gonna do is I'm gonna type in the square root of, I'll do the gray square first, so 77.44. So I'm using that symbol there to figure out what the side length would be. So that looks like, to me, the side length is going to be 8.8. So anytime I see those gray squares, I'm getting a side length of 8.8. So this one here would be 8.8, and same thing with this one. And then there's a third one at the bottom. Perfect. Now let's do the same thing with the black squares. That's going to be 2.2. Now, since our question is asking us to figure out the height, what we need to do is add all of these numbers together. So we're gonna add, technically I'm gonna go like this. I'm gonna go 3 times 2.2 plus 3 times 8.8. So when I do that and punch that all in, I'm gonna get 28.6 centimeters. So that means my answer to the nearest tenth would be option A. Okay, numerical response number 4 here. So we have an incomplete shape here, and it's got a line of symmetry shown below. So right here, that's our line of symmetry. What we want to know is if we were to complete the diagram, how many dots would be inside the shape. So this one's kind of a nice one. We get a little bit of a break from some of those calculations. What we're going to do is we're actually going to do our best to draw this as if it was symmetrical. So remember, if something is symmetrical, what we're saying is that everything on that line is exactly proportional to everything else on the line below, or on the other side of that line, excuse me. So what I'm doing is I'm drawing dots on kind of where these points would be, where I would expect to draw them, and then I can connect my dots to represent the figure. Now, on your test, you might not have a ruler, and that's okay. You'll just do your best. They are designed to be done without a ruler from my understanding. Okay, so there's our shape. And then we can see, well, okay, well, how many points are inside it? I've got 1 point, 2 points, 3 points. So therefore, our answer is going to be 3. All right, number 19 here. So with this one, what we want to do is we are looking at this division question here, and we are wanting to find out which tiles or which models are going to represent that question there. So for something like this is one of those ones where, again, I say, let's not look at the options. Let's come up with what we know is the right answer and then compare it to the options there. So let's think about what we've got going on here. We've got a binomial 6x squared minus 3, and we're dividing it by 3x. So that means when I set up my tiles, we normally start with like a little bit of almost like a T-chart. And we know that our larger polynomial is going to go on the inside of that. So 6x squared, and it's positive, so I'm just gonna leave it blank and just draw 6 of these guys. So it's 6x squared, and then we've got negative 3x. So we're gonna use a bar to represent that negative 3. Okay, perfect. So now we're saying we're dividing that by our 3x. Excuse me, we're dividing it by negative 3. So if I'm dividing it by negative 3, what that means is I'm going to probably use the same tile, but it's going to be on the outside there. So it's going to be on the outside. It's going to be on the outside there. So 1, 2, and there's 3. Okay, now we can probably go work backwards and figure out our answer. So I know if it's a negative and I'm dividing it by negative 3, I'm looking at tiles that are also going to be negative. And then I would have one tile here. Okay, that looks good. Now, one thing I didn't look at, so let's look at it now. So the PAT likes to do this. They like to switch the key on you on deciding which one's positive or negative. So in retrospect, I should have gone back and done it, but that's okay. So they're saying here, if it's shaded, it's positive, okay? So we're gonna have to keep that in mind. That means my picture is gonna be the opposite colors of it. So I'm looking for 6 boxes on the inside. Well, they all have 6 boxes on the inside, but we know the 6 boxes have to be positive, in this case shaded in. So that means I can cross off these 2. And then we know we've got our, we're dividing it by negative 3x on the side there. So I only see this one and this one that's divided by 3. We know our 3 is negative, so it could be A or C. What I do know is that when I got my answer, I had a swap in signs, which makes sense, right? One of them was negative, the other was positive. So that means I'm going to be looking at option A as my answer. And that's because when I divide this, I'm gonna get negative 2x plus 1, which is right here. Okay, I hope that makes... Okay, so our answer is A. Okay, number 20 here. So they gave us a diagram, and what they said was the shortest edge of the diagram is going to be 64. So that means our shortest edge here is 64. So you might be wondering, okay, well, how does that help us? Well, we know that it's A squared is equal to 64. That's going to be important because this goes back to knowing our perfect squared. So what we're saying is A times A is equal to 64. So we're saying what 2 numbers are the exact same that equal to 64. Well, if we remember our square roots or just our multiplication table, we know that A is equal to 8. Okay, and I can show you that here as well. If it's a perfect square, we can go with the square root of 64, and that's going to be 8. Now, our job is to figure out the length of the longest edge. So here's our longest edge, and it's made up of A to the power of 4, which really means we're saying 8 times 8 times 8 times 8, A to the power of 4. So I actually can pop that in here because that wouldn't be a number I would say that they would expect you to know. So 8 to the power of 4, oops. 8 to the power of 4, we can calculate that. That's gonna get me to answer D. So there's our answer for this question. Okay, number 21. The organizer of a 16-team soccer tournament wants to conduct a survey to determine the minimum number of games each team in the tournament would like to play. Which of the following samples would provide the most reliable results for her survey? So what we'll need to do is go through each one's here and decide which one would give the best way of collecting information so there's no misinformation here when they're presenting their results. So one player from each half of the team. Well, we probably wouldn't want to do that because not everyone would have input. We want to make sure if we're looking at this, every person is represented, at least as much as possible. For B, every fourth team that registers in the tournament. Well, if there's a 16 teams and we're looking at every fourth, we're then going to be excluding quite a bit of that sample population. That's not going to work. For C, 3 randomly selected players or coach from each of the team. So that might be good because we're getting random selected players or coaches from each team. They're random. There's no kind of way that we could get a little bit of bias if it's random. So I am liking that answer. For D, all the players and all the coaches from one team, all the players and coaches from one randomly selected. So we could do that, but if it's from one team, it doesn't represent all the other teams. So in this case, our best answer here is going to be C. All right, number 5 here. In 1 month, Dale earned $180. He earned $45 by washing cars and the rest by mowing lawns. How many lawns did Dale mow if he received $9 for each of the lawn that he mowed? Okay, so this kind of goes back to that question with those rental cars. We kind of need to devise a little bit of an equation here, or come up with the ways that the two numbers come together to figure out the remaining, okay? So one of the things that I'm looking at this is we know that if it says for each, well, we can say that that would be 9x. $9x. And the reason I say it's x is because we don't know how many lawns he had, but each is a fancy way of saying multiply. So we know if it's $9 for each lawn, it's going to be 9 times that unknown. We also know that the total he earned was $180. Now we know that out of the $180, $45 was made by washing it. Okay, so let's set up our equation here. So $180 is equal to $45 plus our 9x. Okay, so now what we can do is just solve for x. I can take away 45 from both sides. That's gonna get me 135 is equal to 9x. Now I just have to get x on its own, divide both sides by 9. And so x would equal to 15 lawns. Okay, number 22 here. So this one, they're really just testing your knowledge of rational numbers here. So I'm going to kind of give you a strategy for this one that works really well for this specific question. So we know we've got some variables Q, R, and S, and they represent our rational numbers. So rational numbers we know are really positive and negative numbers. They could be fractions, decimals. They just can't be irrational like pi, like the number pi. So what we do know is Q is bigger than R. And we know S is equal to Q plus 1. So whatever Q is, if I add 1, I'm going to make sure that that's going to equal S. Okay, so one thing that I'm looking at is when it comes to these number lines, they gave me -10 and +10. So I'm going to take a little bit of a leap of faith here and I'm going to say, well, okay, if this number is in the center of that number line, it probably has to be 0. So let's say then that if S is 0, well, we know that Q plus 1 has to equal S. Therefore, by that definition, S can't actually be 0 in this one. So that means I can cross off anything with S in the middle if we're assuming it to be 0. So that crosses off that. I'm actually going to cross it off here as well. That leaves me with option B and D. So what we do know is Q has to be bigger than R. Well, let's think about our number lines. If this is 0, then Q has to be bigger than R. Well, when I move to the left of a number line, we know that our numbers actually get smaller. So that means R could not be on this side of Q. So that means our only answer is going to be answer B. Now, something else we could do with this question is we could, if you're unsure of it, you can substitute some numbers in here. So why don't we actually quickly go ahead and do that before I wrap up. So if this is 0, then we know Q plus 1 would equal S. Well, if this is 0, 0 plus 1 would be 1. And then R would have to be less than Q. Well, if this was -1, for example, that would work. It would fall on those parameters, even though that those aren't the exact numbers. Okay, so that's it for this one. This one's gonna be D. Number 23 here. So with this, what we have is we've got Alice works 8 hours a day as a waitress in a restaurant. She earns $12 an hour plus money received from tips. We want to know which equation would best represent her earnings. So her earnings are represented as E, which is our total. So let's think about what's happening here. We have our total, and that's going to equal the amount she earns per hour. So as I was saying in the previous question, if it's per hour, that's going to be something we multiply that number by. Now we know she worked 8 hours. So instead of being a variable here, we know we're going to need to take our amount that she earns per hour times it by the hours that she worked. So that already tells me this is going to be 8 times 12.50. And then it says plus tips, but we don't actually know what her tips are. We just know it's a little t. That means with everything here, we're going to have to add the tips to the amount of hours she works to get the total. So now let's go back and fill it in with how they want us to answer this question. Well, they want E to represent the total. So we can say E is equal to 8 times. So I'm just going to write it like this. It's both the same thing. We can rainbow in that 8 plus the T. So the option that matches this one is going to be option A. Number 23. Okay, number 24 here. So what we want to do here is they've given us a graph, as we can see. And what they're saying is, in this graph, they gave us 2 equations. We want to know where those 2 equations are going to intersect, and specifically at which point. So when we think of an equation, especially a linear equation like this, they're basically 2 lines. And what they're asking us is which point on the graph would those 2 lines intersect. So I like to solve this just using some algebra here. So what I'm going to do is I know that all of these coordinates are my x and all of these coordinates are my y. So what I'm looking to do is subbing in these x values wherever there's an x in this equation, and subbing in the y values wherever there's a y in that equation. What's going to happen is if those points intersect, you're going to get the left-hand side equaling the right-hand side when we sub in these values. So let me show you what I mean for that. So what I'm going to do is I'm going to write a little bit of a template here where I'm saying in the place of the x and the y, I'm going to be inserting those points there. And I'm just drawing the brackets in there to remind myself that I'm putting in some numbers. So for the first point, what I'm putting in is I'm going to put in 0 and 1 wherever there is an x and a y. So when I solve this, I am getting 1 equals 17. And for this one, I'm getting 1 equals 1. So while one of them, it does work, this point does work, if it was a line that intercepts, this would be 17 on both sides. So that means A is not an option. Let's look at option B. Okay, so for this one, we're getting 3 times 3 is 9, plus 8 equals 17. So that does work for that side. On this side, we're getting 8 equals 4. That does not work on that side, so option B won't work. Let's try C. Okay, so for B, I'm getting 12 plus 5 equals 17. So that one I do like, that 17 is equal to 17. For the opposite side, I'm saying 5 equals 4 plus 1, which is equal to 5. So that one does work. Let's just verify that D is not an option. So this would be 15 plus 4 equals 17. Well, that would be 19 equals 17. That's not going to work. This one would be 4 is equal to 6. That one doesn't work. So our option is going to be C. Now, what we could also do if we wanted to is we could use these values here, create a table of, use our exponents, create a table of values, plot those values, and you're going to see there's a point where both equations share the point 4, 5. Okay, numerical response number 6 here. So one thing we do want to remember is going to be this here, our perfect squares. So our perfect squares are basically two numbers that are the exact same that multiply a number. And when we take the square root of a perfect square, we get the answer of it. So what we need to do here is they gave us some numbers and none of them are perfect squares. But we want to assume that if we can estimate what the perfect squares are, where they would line up on this number line here. So let's look at our first one. So our perfect square of 37. Well, I know the closest I can get is going to be 6. So I know the square root of 6 is equal, I know the square root of 36 is equal to 6. That means this number is probably a little bit bigger than 6. So I would say it's going to be about 6.1, okay? Now let's look at our next one. Our next one is 8. Well, the closest I can get for a square root of 8 would be 9. That'd be 3 times 3. That means this one is probably close to about 2.9. Square root of 22, well, that's going to be somewhere in between 25 and 36. So the square root of 22 is going to be about, I would say, let's guess about 4.8. I could be wrong about these guesses, but it gives us a good little kind of benchmark. Square root of 41, I would say that one would be closer to 6.5 because the closest I can get would be square root of 49, which is higher than 49, that's about 7, and then our square root of 36, which is 6. All right, square root of 6, it's probably going to be close to about 5, or excuse me, not 5, probably close to about 2.5 is what I was trying to say. Maybe even 3. Yeah, let's say, yeah, I'll keep it at 2.5. Square root of 50, that's going to be about 7.1. Square root of 27 is probably going to be about 5.2. Square root of 32, it's going to be less than 6, so let's go with 5.8. So again, just estimations to give us a rough idea. Now we want to know, well, okay, if here's our estimations, we want to know which code is going to be represented up here. So let's see, W, what's the closest of W? So I'm going to fill in my number line actually before I get into that. So 2, 3, so I just filled in my number lines with some of those missing numbers. And now let's look at where W would go. So W looks like it's less than 3, really close to 3. So I'm gonna look at a square root that's really close to 3. I'm getting, it's going to be about code 2. So that means I'm gonna put a 2 right down here. Okay, our next one is X. This looks a little bit bigger than 4. The one that I have that's a bit bigger than 4 is about square root of 22. Now I know the square root, oh, I made a mistake there. Okay, after I fixed my number line, we're looking at 5. So we're looking at something that's slightly bigger than 5. That's gonna be about number 7 here. And then for our next one, we're looking at something that's a little bit higher than 5.5. That one to me is gonna be number 8, the square root of 32. And then our last one is a little bit bigger than 6, but less than 6.5. That to me, I know I was saying it was gonna be 4. And this is the one I was a little concerned about. So let's think about it. If it's 41, 41 is about less than there, right? Because it's not quite 7, that would be closer to 49. So for this one, I would say it's probably going to be code number 4. So our answer for this questions are 2, 7, 8, and 4. Okay, number 25 here. So this one's a little bit of an interesting one. So David creates the table of values shown below based on the designs he assembles using black and white 2D shapes. So what we do notice is the number of black shapes, those are always increasing, but the white ones are always increasing by 2. So I'm just gonna add that. So what that means is that these are increasing by 2. It means the black shape is actually dependent on that W. That means this is gonna be 2B. Okay, so anything really without a 2B is gonna work. So that's saying 2B plus 3 equals W. And we can just double check this as well. So for example, if I say, let's plug in these values here. So I'm gonna say 2 times 4 plus 3, that should give me 11 if I did it correctly. So 2 times 4 is 8, plus 3, yep, that gives me 11, which is the number of shapes. So our answer here is going to be D. Okay, number 26 here, we are looking at polynomials. So we're actually looking at subtracting polynomials. So one thing I just kind of want to show you before we start, I did create a whole video on polynomials, so make sure you check this out here. That could help you if this question is a little confusing. So there is a little trick to this. So I'm going to stack everything first, just the same way we stack things when we were learning math in elementary. So all I did was I made sure my x squares, my x's, and my numbers were together. Now with this question, we're subtracting. So we actually can use a little bit of a trick where we can say that we're going to pretend we're adding, and then we're gonna flip the signs of everything in here to the opposite sign, okay? Now we can just go ahead and add like normal. So I'm gonna start from the end. So this is gonna be 24, negative 5x, plus negative 8x. So basically I've got a bunch of negative tiles here. That's gonna give me negative 13x. And then with this portion, we've got x squared. And we're adding 3 negatives. So I have 3 negative tiles and I'm adding 1. That's gonna leave me with negative 2x squared. So altogether, that means my answer is going to be option A. Okay, last question here. This is number 27. And so what we want to do is we've got point O in the center of the circle, and we want to figure out the value of x. So a couple of things that are probably coming to mind at this point. We know we have our central angle. Well, we've got part of it anyway, and we've got our inscribed angle. So remember, our central angle, whatever this whole angle is, let me zoom in so you can see that. Whatever our whole angle is, when we cut that in half, that's gonna give us our inscribed angle, which is what we wanna find out, right? We wanna find the value of x. So what's tricky about this one is they have only given us a portion of that central angle. We need to figure out the rest. So let's see what we've got here. We have a triangle. And then we need to carefully think, and I agree with some of you that might be thinking, what kind of triangle is this? Or how do I figure this out? So it's not the best diagram in my opinion, but if we look at it closely, we can see the bottom are the same size. So this is again an isosceles triangle, meaning this portion here has to also be 75 degrees. Okay, so if that's 75 degrees, we know all the angles in a triangle add up to 180. So we can use our 180, take away 75, plus 75. That's gonna get me to a total of 150. So now I can say, well, all the angles in the triangle in this triangle here are 150, or excuse me, are 180, take away 150. That's gonna leave me with our missing portion of 30 degrees. So I can now that I have those pieces together, I can put them together as my central angle. So my central angle is 94 plus 30. That's gonna give me 124. So our answer isn't 124, but we can use that. That's the central angle. So once we take half of 124, I'm going to get 62. So that means this angle here is 62 degrees. So the answer for this one is B. Okay, number 28 here. So what we're gonna do is we've got on a bike trip, Patrick rides a constant speed of 14.4 kilometers for 3/4 of an hour. And then at a constant speed of 3.2 kilometers per hour for 1/3 of an hour. And we want to know how many kilometers in total did Patrick travel on the bike trip. So in order to do this, we actually need to take our numbers in kilometers per hour, those numbers there, multiply it by the fraction of how many hours that took and add them together. So that's going to look something like this. So this is going to be 14.4 kilometers per hour times the 3/4. Add that to our 13.2 kilometers per hour and times that by our 1/3. Once we do that, we are going to get this portion here to be about 10.8. Add it to this portion here, so that's going to be 4.4, and that's going to give me a total of 15.2 kilometers. So our answer is this right here. Okay, number 29 here. So with number 29, they gave us a key here, and our job is to figure out which one of the following are like terms. So like terms basically means they have to have the same variable and the same exponent. Now, if you don't remember how to do this, I strongly recommend you check out my video here, where I actually go through all the like terms with some guided notes, and I use emojis, so it doesn't feel like it's super mathy, if that makes sense. But let's decide here which ones have the same exponent and the same variable. So this one has the same variable, it's 3x, but these ones here are x squared. So this is saying 3x, and this is saying 3x squared, so those two are not the same. This one is saying negative 6x squared and negative 6. So the tiles here do not represent the same thing. These just represent numbers, and here we're saying there's a variable, so it is not B. For letter C, we're saying it is an x, but again, the diagram here are just these little tiles. Those are just numbers, and here we have a variable. That's not going to work. So let's verify our last one. Here we're saying we've got an x. We technically have negative 4x, and we want to know which one would be a like term. Well, the only one that has an x in it are these ones here. So that means our answer is going to be D. So D represents like terms. I hope that was helpful. All the interactive tools to help you learn and study are in the description below. Just as a reminder, I do hold one-on-one sessions. You know where to find that information, and I will see everyone in the next video.